Hi everyone, this is our lecture on the rate-determining enzymes of metabolic processes. So let's get started. To get a clinical perspective, let's look at a quick flash case. Let's say a 22-year-old medical student presents to his primary care physician with fatigue and jaundice. He was last seen in the office only 3 days ago, in preparation for his upcoming volunteer trip to Africa. Let's keep this in mind as we go through the lecture. Our learning objectives are to list the rate-determining enzymes of metabolic processes and to recognize the regulators of rate-determining enzymes and their metabolic processes. Here, we have a table of the different metabolic processes in the first column, the rate-determining enzymes in the second column, and the regulators in the third column. Now, yes, I recognize that this is very overwhelming, but it condenses some of the most high-yield information regarding the processes into one table. The enzymes in particular are some of the most commonly tested enzymes, since they determine the rate at which a reaction can occur. The rate-determining enzymes are also the ones most commonly targeted by drugs, because slowing them down or speeding them up will influence the process they're involved in, which might not be the case for the other enzymes in the pathway. It'll definitely help you to know which enzyme is rate determining for each process and how these enzymes are regulated. Now, we won't discuss all of these as that wouldn't be worth your time, but we will discuss a few as well as some clinical tie-ins. Let's take a closer look at glycogenesis, or the creation, storage of glycogen, and glycogenolysis, or the breakdown of glycogen into glucose. As you can see, the inducers of glycogenesis are the inhibitors of glycogenolysis, while the inhibitors of glycogenesis are the inducers of glycogenolysis. And this all makes sense looking at the diagram. These two processes are opposite sides of the same coin and are involved in glycogen metabolism. If you have plenty of substrate around in the form of glucose 6-phosphate, you will induce glycogen synthesis. And the same goes if you have insulin or cortisol present. Now, this process is inhibited if epinephrine or glucagon are present, and this is done through protein kinase A, as you see here. Now, one quick tie-in here is that in stressful situations, you want plenty of glucose available for the body to use. This is why epinephrine leads to the inhibition of glycogen synthesis and stimulates glycogenolysis. Another tie-in is related to insulin-dependent diabetes. Here you are providing insulin to help improve blood glucose levels. This insulin is going to stimulate glycogen synthesis and inhibit glycogen breakdown via protein phosphatase, as you see here. Now, patients using insulin are at risk of developing hypoglycemia, and every patient that is given an insulin prescription should also be given a prescription for a glucagon kit. Can you tell me why? Great. That would treat hypoglycemia. Glucagon would stimulate the breakdown of glycogen into glucose, increasing blood glucose levels. Often, in severe hypoglycemia, patients are too obtunded to realize they need to eat, or for a family member to be able to safely give them food to increase their glucose levels. In this situation, glucagon is administered intramuscularly to help relieve the hypoglycemia. Another common example is HMG-CoA reductase, which is the rate-limiting step in cholesterol synthesis. HMG-CoA reductase converts HMG-CoA to mevalonate, which eventually gets turned into cholesterol. Do you remember which class of drugs inhibits this enzyme? Great! The HMG-CoA reductase inhibitors, or statins, which are used to treat hypercholesterolemia. Therefore, statins inhibit the rate-limiting step for cholesterol synthesis. Let's talk about one more, the hexose monophosphate or HMP shunt, also called the pentose phosphate pathway, which parallels glycolysis to create NADPH and products for nucleotide, nucleic acid, and amino acid synthesis. Its rate-limiting enzyme, as we can see in this diagram as well, is glucose 6-phosphate dehydrogenase, often abbreviated as G6PD. Why would it matter if we had a deficiency in G6PD, which is a common human enzyme deficiency and it's X-linked recessive? Well, G6PD forms NADPH from glucose 6-phosphate, and NADPH is necessary to keep glutathione reduced because it detoxifies free radicals and peroxides. Decreased NADPH in our red blood cells would lead to a hemolytic anemia, because then we'd have weak defenses against oxidizing agents, including sulfonamides, anti-tuberculosis drugs, and antimalarials. Infection can also precipitate hemolysis. When the globin chains get denatured and precipitate within the red blood cells, they form Heinz bodies, as you can see here. Great. Let's do a quick flash quiz. What is the rate-determining enzyme of glycogenolysis? Yes, glycogen phosphorylase is the rate-determining enzyme of glycogenolysis. Extra credit if you thought of the regulators too. Well, let's go back to our flash case. Hey, didn't we just see that image? You're right if you're saying those are Heinz bodies from the denatured globin chains that are precipitated in red blood cells due to oxidative stress. But what is stressing out a 22-year-old medical student? Well, besides medical school. He's planning a volunteer trip to Africa, and a few days ago, he may have been prescribed an antimalarial, like chloroquine. If he is deficient in glucose 6-phosphate dehydrogenase, then he doesn't have enough NADPH to defend against oxidizing agents. Well, we've made it to the end. If you're looking for more, do not despair. All of these enzymes will be covered throughout the biochem metabolism section, but this is a great review table, so please make sure you have a firm grasp of these enzymes and regulators prior to test day. What's the bottom line? Rate-determining enzymes determine the rate at which metabolic processes occur and are controlled by numerous regulators. And rate-determining enzymes are frequently targeted by drugs to speed up or slow down a metabolic process. That's all I have for you here. Please give this video a thumbs up if you liked it, and it'll give you the opportunity to submit a comment if you have any feedback or questions. Thanks for joining me. Study hard.